continuing with example 1, we had the interest from the 30-year loan as $258,732. We're going to explore what might happen and how much interest we might be able to save if we had been able to take advantage of the bank's 15-year rate, which was only 3%. Now, of course, that's going to increase our payment quite a bit because we're going from 30 years to 15 years, but we are also going to be saving a lot in interest with that 1% in decrease. And this is actually something that happens, so it's always a good idea to check it out and see if you can make it happen. All right, so let's use the formula first, and then we'll use this over here. So again, R is equal to, see what our payments are going to look like. We could have the principal, again, of $360,000. I is R over M, so this time R is 3%, and we're still compounding monthly. And then 1 minus 1 plus R over M to the minus MT. Now, we're not doing 30 years, we're doing 15 years this time. So getting it paid off quicker. All right, again, if you want to write down your keystrokes, let's see, we've got $360,000. Let's see how I did with my parentheses here. So we've got this power. I did it one more time, almost dropped that extra parenthesis off, so that whole binomial there is raised to that power. I've got that fraction in parentheses. This is my entire denominator. And I did, let's see, put this here. Actually don't need that parenthesis there. So I could put one here and here if I wanted to have that with the 360,000. Okay, so 360,000 and then 0.03 over 12. Alright, so payment went up quite a bit, $24.8609. Let's see what the difference in that payment was. $17.18.70. So about a $767 difference in the payment. Let's use the TVM solver. We've got MT, so that's 12 times 15. The interest rate now is 3%. Present value of the loan is still $360,000. Payment, what we're trying to figure out, future value is going to be 0, and payments per year, compounding periods per year, and let's see what we've got there. So apps, finance, all right, so 12 times 15 this time, percent is 3, and then let's go back to payment and do alpha enter. So there we see the $24.8609 per month. But that's not actually the answer we're looking for here, so I probably shouldn't have boxed that in. But we could figure out how much we would actually be paying in interest. So interest would be how much we've paid into the bank minus the present value, how much the loan was actually for. So how much we paid into the bank would be that payment amount times how many payments we made. Well, there's 12 months in a year. And this time we did that for 15 years, or the couple did it for 15 years, and we're going to subtract out the amount of the actual loan. So if we took $24.8609 times 12 times 15, that means we paid in $447,496.20. And if we subtract out $360,000, then we've only paid in, or they've only paid in, $87,496.20 in interest. So this is not actually the answer I'm going for here. The question actually asks, how much interest would they have saved? This is how much interest they paid if they got the 3%. This is how much interest they paid at the 30-year rate. So if we wanted to know how much they saved at this rate, then we would have to do what with these two numbers? Well, yeah, we would have to subtract. So we could take 258, 732 minus 87, 496.20. Wow, they're going to save $171,235.80 in interest. So that's pretty amazing. 171,235.80 saved in interest. So it might be worth that extra $700 a month if you could swing it. Here's another example of comparing interest rates. We've got a price of a new car being $12,000. We're assuming that an individual is going to make a down payment of 25%, 1/4, toward the purchase of the car, and then they're going to finance the rest. Looks like they've got an 8% per year compounded monthly, and we're going to compare how much interest they're going to pay over a 36-month period versus a 16-month period. So those are common periods to finance a car when you go car shopping. We can do that with the formula, or we can use the TVM solver, either way. And we're also looking at the payment. So let's go ahead and figure out the payment first, and then we'll worry about the interest. So R is equal to, we got to figure out how much our loan's going to be for first, okay? So if we're paying 25% down, that means we're only financing 75% of the car. So we're going to take 75% of $12,000 is financed. So 12,000 times 75%. That's how much our loan is for. That's our P, 9,000. So we're going to have 9,000 times R over M. So what's our R? What's our rate? Right, R is equal to 0.08, and P is equal to 9,000. So I've got 0.08. This is compounded monthly, so over 12. And in the bottom, I've got 1 minus 1 plus R over M to the minus MT. So M is 12, and we're looking at, let's go ahead and make this one the 36 month, so that's T equals 3. So we'll just go ahead and multiply MT and get minus 36 there. Alright, so typing this in, we've got a payment of $282.03. Not a bad car payment. So if we check this with the TVM solver, N is equal to MT, so that's 36. You'll type in 8 for the percentage. Present value is the loan price, or the loan amount is 9,000. Payments what we're trying to figure out. Future value, we have to pay it off, so it's going to be 0. And then payments are going to be 12 compounded monthly, so then 12. So we're going to go to apps, type in 36, interest rate of 8, and we're only borrowing 9,000. Trying to figure out the payments, and future value is 0. So on payment, you're going to hit alpha enter, and that's where we see the 282.03. So let's see how much interest we're actually going to be paying on that particular loan for 36 months. So interest is going to be the amount paid to bank minus the loan amount minus the present value. So we only borrowed 9,000, and the way we figure out how much was actually paid into the bank is we take that payment and multiply by how many payments we made. So we made 282.03 how many times? 36. So times 36, let's go ahead and round that. 282.03, and take away 9,000. Looks like we paid $1,153.08 in interest. Let's go ahead and do the same thing for the 60 month. So here the only thing that's going to change is going to be the time, because everything else remained constant. So T here is going to equal 5 years, which is 60 months. So R is going to equal 9,000 still, and then 0.08 over 12, still compounded monthly, and then 1 minus 1 plus 0.08 over 12. And instead of minus 36, we're just going to have to the minus 60. So we should be able to go back through here, second enter, until we find that expression. And let's just go ahead in the exponent and change that to a 60. And everything should be good. So this is going to be around 182.49. And we should get the same thing in the TBM solver. So MT, that's going to be the 60. The interest rate is still 8. Present value is still the 9,000 loan value. Payments, what we're trying to figure out. Future value, we have to pay it off. And then compounded monthly. So apps, this time we got 60 for MT. And we're trying to figure out what is that payment. Alpha enter, it's 182. So if we wanted to figure out our interest on this one, we would have the payment, but this time we're making 60 payments, 5 times 12, 5 years, 12 times. And the original loan amount was 9,000. So 182.49 times 60 minus 9,000. So we paid quite a bit more. If we take 1949.40 and we subtract the 1153.08, we're going to get a difference of $796.32. So these are my payments, and the question was, what will the interest charges be if the individual elects the 36-month plan, the 60-month plan? So this is the interest for the 36-month. This is the interest for the 60-month, and then the difference between the two, which I don't think it actually asked that question, but it's a good one to look at, because that's something you'd look at if you were buying a car.